66 million years ago, a predator ruled the land with jaws strong enough to crush bone, eyes sharp enough to track prey across miles, and a body built like a living tank. Its name was Tyrannosaurus Rex. To most, it's the face of prehistoric terror, the ultimate apex predator. But what if I told you T-Rex was not the beginning of the story, but the end? What if it wasn't just a lone king, but the last ruler of a long, ruthless bloodline? The Tyrannosaurids were not born tyrants. They evolved slowly, steadily, across tens of millions of years, from dog-sized ancestors in the Jurassic forests of Asia to continent-dominating behemoths like T.rex and Tarbosaurus. Their story is one of survival, adaptation, and dominance. It's a story that spans entire continents, from Alaska to Mongolia, from the deserts of Utah to the ancient floodplains of Alberta. Tyrannosaurids rose to become the top predators of the late Cretaceous world. But to understand how they conquered so much, we need to go back to where it all began. Not with giants, nor with bone-crushing bites or towering frames. The story of Tyrannosaurs begins not in dominance, but in obscurity. More than 165 million years ago, in the lush floodplains of what is now England, a small, lightly built predator moved through the ferns and undergrowth. It lacked the size, the strength, and the reputation of its famous descendants. There were no crushing jaws, no massive legs, no thunderous footsteps. But in its delicate skull, long, narrow, and crested, lay the earliest clues to something far greater. It wasn't a tyrant yet, but it would be remembered as the first step toward one. Its name was Proceratosaurus. Our story begins in the Middle Jurassic in what's now the quiet countryside of Gloucestershire, England. Here, buried in ancient limestone, paleontologists uncovered the skull of a small predator, the only known remains of a dinosaur now called Proceratosaurus. At first, it was mistaken for something else. When it was described in 1910, it was lumped in with Megalosaurus, the catch-all theropod of the time. But by 1926, it earned its own name, Proceratosaurus, meaning before Ceratosaurus. That name came from a presumed connection between the two, mostly due to the small crest rising from its snout. Today, we know that resemblance was just a coincidence. Instead, it belonged to a completely different group, the Coelurosaurs, a lineage that would eventually give rise to both birds and tyrannosaurs. The skull itself measures just under 27 centimeters or 10.6 inches, and the whole animal likely stretched about 3 meters or 9.8 feet from nose to tail. It was no giant, but its anatomy is revealing. The slender skull had a distinctive crest starting where the premaxilla meets the nasal bones. Its teeth were heterodont, D-shaped and blade-like at the front, with serrated edges farther back. That's a hint it hunted small prey, possibly lizards or mammals. But what really sets Proceratosaurus apart is where it sits on the dinosaur family tree. It's one of the earliest members of the group Tyrannosauroidea, the broader family that would, tens of millions of years later, evolve into giants like Tyrannosaurus Rex. Alongside relatives like Guanlong, Proceratosaurus represents the humble beginnings of the dynasty. Its fossil comes from the Great Oolite group, likely from either the white limestone or the forest marble formations. Back then, southern Britain was part of a chain of subtropical islands, warm and seasonal, where dinosaurs like Megalosaurus, Cetiosaurus, and early armored dinosaurs also roamed. While we don't have any direct skin impressions, fossils of its close relatives, like Yutyrannus and Guanlong, show clear evidence of primitive feathers. According to paleontologist Dave Hone, it's safe to assume Proceratosaurus was feathered too, probably with soft, down-like plumage. The skull of Proceratosaurus was long and narrow, over 3 times as long as it was tall, giving it a sleek, streamlined look. At the front was the external nares, the bony nostril opening making up about 1/5 of the skull's length and angled slightly upward, a key difference from its cousin Guanlong, whose nostrils pointed straight ahead. Just behind that was the triangular antorbital fenestra, a hallmark of theropods, measuring nearly 7 centimeters or 2.8 inches. Surrounding it was a deep fossa, but in Proceratosaurus, this hollow extended unusually far forward, downward past the promaxillary foramen, a unique feature that helped set it apart. The eye socket was only partially preserved, but its outline suggests an inverted egg shape, probably a little taller than it was long when complete. At the tip of the snout, the premaxilla was short and rounded, forming the upper jaw's front. A crest started here, built on the nasal bones and upper edges of the premaxillae. Though only partly preserved, it likely arched over the snout and hung over the top of the nostril, a unique feature of Proceratosaurus. Like its relatives, it probably had a hollow, air-filled crest covered in keratin. Earlier ideas compared it to Ceratosaurus's horn, but after discovering Guanlong, that became the better comparison. The maxilla, the main tooth-bearing bone, was long and slim, about 16.3 centimeters, 6.4 inches, over half the skull's length. Its front edge differed noticeably from Guanlong, and the jugal bone contributed little to the edge of the nearby fenestra. The teeth showed classic theropod variety. The front premaxillary teeth were D-shaped, while the side teeth were narrow, serrated blades, perfect for cutting flesh. The front lower teeth stuck out slightly. Tooth counts were about 4 per premaxilla, 22 per maxilla, and 20 per dentary. Tiny serrations or denticles were rounded and most dense at the front and back of the upper jaw, but evenly spaced on the lower jaw. A delicate hyoid bone supporting the tongue, measuring about 12 centimeters, mostly straight with curved ends. It's a small but telling piece of Proceratosaurus's anatomy, from crest to swallow. We don't know much about the overall biology of Proceratosaurus because its postcranial bones, basically everything except the skull, haven't been found. But thanks to what we do know about its close relative Guanlong, we can make some educated guesses about how Proceratosauridae lived. Like all early tyrannosaurids, these dinosaurs were carnivores. One big difference from later tyrannosaurids like Tyrannosaurus is their arms. Proceratosaurids had relatively large, strong forelimbs, probably used to grab and hold prey. Later, cetaceous tyrannosaurids, on the other hand, had tiny arms and likely relied mostly on their massive heads and powerful neck muscles. Despite these differences, Proceratosaurids already shared many key features with their later relatives. For example, their nasal bones were fused together, a trait inherited by later tyrannosaurids. This fusion likely helped their skulls handle the intense forces generated during biting. Back then, Proceratosaurids already used the puncture-pull feeding style. This means after biting into prey, they'd pull their heads back to rip flesh off, slicing through it with their teeth, a feeding method common among many coelurosaur theropods. A 2023 study estimates its bite force to be about 390 newtons, around 88 pounds of force. That's similar to the smaller Tyrannosauroid Guanlong, but much weaker than adult Tyrannosaurids. The study showed that Proceratosaurus's skull wasn't as strong at handling stress as those of its bigger cousins. The crest on its head might have helped distribute biting stresses, supporting the skull when biting down. Later, it was proposed the head crest wasn't for fighting, but probably served as a display feature, something to show off. This was backed up by Gregory Paul, who pointed out the crest was too fragile to be used for headbutting. Building on what we know about early Tyrannosauroids, Guanlong is a fascinating example from the late Jurassic of China. Discovered in the Shishugo Formation around 160 million years ago, Guanlong, which means crowned dragon in Chinese, was officially described in 2006 by Xu Xing and colleagues. It's known from two specimens found stacked together, an adult and a nearly complete juvenile, which gave scientists a rare look at how this dinosaur grew. Guanlong was a relatively small predator, about 3 to 3.5 meters, or 9.8 to 11.5 feet long, and weighing roughly 125 kilograms, or 276 pounds. One of its standout features was a large, thin, and delicate crest sitting on top of its head, likely used for display, maybe to attract mates or signal others. Interestingly, the juvenile's crest was smaller and limited to the front of the snout, while the adult's was bigger and stretched further back, showing how this feature developed with age. Unlike its famous relative Tyrannosaurus, Guanlong had 3 long fingers on each hand, probably sported a coat of primitive feathers, similar to its close cousin Dilong. Its skull crest was highly pneumatized, filled with air spaces, making it lightweight yet elaborate, more so than in related dinosaurs like Dilophosaurus and Monolophosaurus. While those creatures might have helped with species recognition, Guanlong's more fragile crest was likely all about show. Studies placed Guanlong in the family Proceratosauridae, making it part of an early group of Tyrannosauroids that had traits linking them to later, more famous Tyrannosaurus. Histological analysis showed that the adult Guanlong was about 12 years old at death, while the juvenile was still growing at 6, highlighting changes like crest size, limb proportions, and skull shape during growth. Moving on from Guanlong, Dilong is another key player among early Tyrannosauroids. Its name means Emperor Dragon in Chinese, and it lived during the early Cretaceous period in what is now eastern China. The fossils came from the Yishang Formation, specifically the Lushatung unit, which dates to roughly 125.8 to 126 million years ago. Dilong paradoxus is the only species known in this genus, and it made headlines when it was first described in 2004, mainly because it was the first Tyrannosauroid confirmed to have feathers, something paleontologists had long suspected but hadn't proven yet. The type specimen includes a nearly complete, semi-articulated skull and skeleton. It was about 1.6 meters long, around 5.2 feet, but that individual was probably a juvenile. Fully grown adults may have reached over 2 meters, about 6.6 feet in length. Dilong would have weighed roughly 6 kilograms, about 13 pounds. This wasn't a giant predator by any means, but it gives important insight into the early evolution of Tyrannosauroids. Dilong had a covering of simple proto-feathers, primitive feathers seen in fossilized skin impressions near the jaw and tail. These feathers weren't like modern bird feathers, they lacked a central shaft and were most likely used for insulation rather than flight. Interestingly, adult tyrannosaurs from later periods, like those found in Alberta and Mongolia, show evidence of pebbly scales instead of feathers. Tyrannosauroids might have had mixed skin coverings, scales in some areas and feathers in others. Seems like feathers were more common in juveniles for warmth and then lost as the animal grew larger and could regulate temperature differently. While initially classified as one of the earliest and most primitive tyrannosauroids, some later studies challenged this. For example, a 2007 study by Turner and colleagues placed Dilong outside the Tyrannosauroid group, instead finding it more primitive than the Compsognathidae, but more advanced than Coelurus. However, many other analyses, including those by Carr and Williamson in 2010, have continued to support Dilong's place within Tyrannosauroidea. Looking inside the skull, brain case scans revealed Dilong had an S-shaped brain protected by thin meninges, unlike the more linear brain and thicker meninges seen in larger tyrannosaurs. This is probably related to size, as similar patterns appear in crocodilians. Guanlong also had a large flocculus, indicating it was agile with good balance but smaller olfactory tracts, suggesting its sense of smell wasn't as developed as in its larger, more advanced relatives. From a single claw spotted along a windswept stretch of the Isle of Wight's southwestern coast emerged one of the early Cretaceous' most intriguing Tyrannosauroids, Tyrannosaurus, the Dawn Tyrant. This genus, named in 2001 after the local fossil hunter Gavin Leng, who first brought the claw to light, reveals a fascinating chapter of the evolution of early Tyrannosauroids. Its fossils, found within the Wessex Formation's ancient plant debris claybeds, paint a picture of a slender, graceful predator roaming a warm, humid landscape some 130 to 125 million years ago. The holotype is a partial juvenile or subadult skeleton composed of skull fragments, scattered vertebrae, and limb bones, each piece telling a story of anatomy and growth. Excavated from a confidential site between Atherfield Point and Hanover Point, this specimen challenges previous assumptions about Tyrannosauroid origins, pointing to a more complex geographic spread across Europe and North America rather than a purely Asian lineage. Detailed study, including a 2022 monograph, highlights unique anatomical features in Tyrannosaurus, such as the unusual shape of its dentary and forearm bones. Although it measured around 4.5 meters or 15 feet in length, this individual was far from fully grown and likely weighed around 150 to 200 kilograms, 330 to 440 pounds, underscoring that early Tyrannosauroids were generally leaner and retained 3 functional fingers, traits that differ from their later, bulkier descendants. Living alongside apex predators like Neovenator and Spinosaurids such as Riparovenator, Tyrannosaurus thrived in a Mediterranean-like ecosystem, preying on smaller dinosaurs and early mammals. Yutyrannus, meaning feathered tyrant, was an early Tyrannosauroid from the early Cretaceous in northeastern China. Known from 3 fossils found in Liaoning province, it's the largest dinosaur discovered with clear evidence of feathers. These finds gave scientists a rare look at what a big, feathered predator might have looked like around 125 million years ago. The species, Yutyrannus huali, was officially described in 2012 by Xu Xing and his team. The species name, huali, means beautiful, probably referring to the dinosaur's striking plumage. All 3 fossils, an adult, a subadult, and a juvenile, came from a single quarry in the Yixian Formation, dating back around 125 million years. The fossils were carefully split into slabs about the size of a bath mat so 2 people could carry them. Yutyrannus was a pretty big bipedal predator. The adult was around 9 meters or 30 feet long and weighed over 1,400 kilograms, around 3,100 pounds. Later estimates suggest it might have been a bit smaller, close to 7.5 meters or 25 feet, and about 1,100 kilograms or 1.2 tons. Its skull was nearly 1 meter long or 3.3 feet for bigger specimens. What makes Yutyrannus stand out are features like a high crest on its snout and hollow bones around its eyes and jaw. Most excitingly, the fossils show clear feather impressions, long filament-like feathers up to 20 centimeters or 8 inches in length. These feathers covered parts of the body like the pelvis, feet, neck, and upper arms. The adult even had tail feathers angled backward. Before Yutyrannus, we knew some smaller Tyrannosauroids had simple, fuzzy feathers, but this guy was huge, about 40 times heavier than the previous feathered record holder, Paleobiology. These feathers probably helped keep Yutyrannus warm in the cool climate of the Yixian Formation, where average temperatures hovered around 10 degrees C or 50 Fahrenheit. Alternatively, if feathers weren't all over, they might have been for show, especially since adults had wavy crests on their snouts that likely played a role in visual signaling. Finding feathers on such a big Tyrannosauroid suggests later, larger tyrannosaurs might have had feathers too. But interestingly, skin impressions from later giants like Gorgosaurus show scales where Yutyrannus had feathers. Some scientists think these big guys might have lost their feathers as they evolved, possibly because of their size or warmer climates. Looking at different aged fossils shows how Yutyrannus changed as it grew. Its legs, feet, pelvis and arms became proportionally smaller, while its skull got stronger and deeper. A 2018 study also found that Yutyrannus had a simple, flat tongue like crocodiles, which fits with what we know about most archosaurs, except birds, pterosaurs and some ornithischians, having fixed tongues. Some paleontologists, including Xu Xing, think Yutyrannus may have hunted in packs. All three known specimens were found together, and the same quarry held sauropod bones, hinting at a possible failed ambush on massive prey. It wouldn't be the first time. Other giant theropods like Mapusaurus also show signs of group hunting. But whether these feathered predators died mid-hunt or were buried together by chance, no one knows for sure. The exact spot where Yutyrannus lived isn't certain, but it probably shared its environment with dinosaurs like Psittacosaurus, Dongbeitian, Sinosauropteryx, and Caudipteryx. The region was a volcanic, forested landscape with lots of rivers and lakes, kind of like modern temperate rainforests in British Columbia, with distinct seasons and temperature swings. Raptorex burst onto the paleontology scene in 2009 as a potential game-changer in understanding of Tyrannosaur evolution, but its story quickly turned into one of the most controversial fossil debates of the decade. The only known specimen, about 3 meters or 9.9 feet long and 65 kilograms or 143 pounds, looked like a miniature Tyrannosaurid, massive skull, strong legs, and 2 tiny two-fingered arms. What made it special was that it seemed to pack the classic Tyrannosaur body plan into a small, early Cretaceous predator, suggesting that their trademark features evolved before they got big. But there was a problem. Its origins were murky. The fossil had passed through the fossil trade, eventually ending up in the hands of paleontologist Paul Sereno, who described it as a near adult from the early Cretaceous Yixian Formation in China, about 125 million years old. Sereno's interpretation was bold. Tyrannosaurs didn't become stocky and short-armed because of their size. Those traits evolved early. But almost immediately the foundation of the claim began to crumble. First, the dating evidence was flimsy. Sereno had cited fish bones and mollusk shells in the rock matrix to place it in the early Cretaceous, but later studies found only a single fish vertebra and a crushed mollusk shell, neither diagnostic. Critics argued the fish wasn't Lycoptera as claimed, but from a broader ranging group, meaning the fossil could be from almost any point in the Cretaceous. Then came an even bigger blow. In 2011, researchers Denver Fowler and Peter Larson reanalyzed the fossil and concluded it wasn't an adult, it was likely just 3 years old. Even more damning, it closely resembled a juvenile Tarbosaurus, a giant Tyrannosaurid from the late Cretaceous of Mongolia. Without solid evidence of age or location, many paleontologists began to suspect Raptorex was simply a misidentified juvenile Tarbosaurus, possibly making the name Raptorex invalid. Further support for a late Cretaceous origin came in 2013 and again in 2022, when 2 separate teams analyzed the fish vertebra found with the fossil. Both concluded it likely came from a species only known from Mongolia's Nemegt Formation, the same formation as Tarbosaurus. Still, not everyone agrees it's a case of mistaken identity. Paleontologist Thomas Carr re-examined the skull in 2022 and found subtle differences, such as the absence of a certain flange on the upper jaw. He argued Raptorex was indeed a juvenile, but one distinct enough to stand as its own genus. Tyrannosaurus. Even the name commands attention. One of the most iconic predators to ever walk the earth, this massive theropod has captivated scientists and the public alike for a century. And at the heart of it all is Tyrannosaurus rex, Latin for king, a fitting title for a creature that once ruled the ancient island continent of Laramidia, now part of Western North America. Tyrannosaurus wasn't just another Tyrannosaurid, it was the most widespread of its kind. Its fossils have turned up in late Cretaceous rock layers across multiple formations, dating from about 72.7 to 66 million years ago. Some tantalizing fragments might even push its origins back a little earlier into the Middle Campanian. Whatever the exact timeline, one thing is clear. Tyrannosaurus was the final chapter in the evolutionary saga of Tyrannosaurids, and one of the last non-avian dinosaurs before everything changed at the Cretaceous-Paleogene extinction event. Like its relatives, Tyrannosaurus was a bipedal predator built for brute force. It had an enormous skull loaded with teeth capable of pulverizing bone, balanced at the other end by a long, heavy tail. Its forelimbs, famously tiny, were still unusually strong and sported 2 clawed fingers. Don't be fooled by their size. They weren't useless. The most complete specimen we have measures around 12.3 to 12.4 meters, about 40.7 feet long. But estimates suggest some individuals may have stretched over 13 meters or 43 feet, stood 3.7 to 4 meters or 12.1 to 13.1 feet tall at the hips, and weighed up to 8.8 tons. Few land predators in Earth's history could rival that size, or the bite force, which is thought to be the most powerful of any known terrestrial animal. In its ecosystem, Tyrannosaurus rex sat confidently at the top. It hunted hadrosaurs and the juveniles of armored dinosaurs like ceratopsians and ankylosaurs. It may have even brought down the occasional sauropod, but like modern lions or hyenas, T.rex probably didn't turn its nose up at a free meal either. Whether it was a fearsome predator or an opportunistic scavenger sparked a long and a heated debate among paleontologists. Today, most agree it was both, an active hunter and a savvy scavenger, depending on the situation. From the early 20th century onward, Tyrannosaurus has become the poster child for dinosaurs. Its image looms large across pop culture, from films to stamps, toys to textbooks. But behind the fame is a fascinating history of scientific discovery, stretching back well over a century. The hunt for Tyrannosaurus rex began long before anyone knew its name. In 1874, a student named Peter Dodson found a mysterious tooth in Colorado. A few decades later, bones uncovered in Wyoming by John Bell Hatcher, once thought to belong to Ornithomimus, may have actually belonged to an early T.rex. Then in 1892, Edward Drinker Cope described 2 massive vertebrae as Manospondylus gigas, believing they came from a horned dinosaur. Later, they'd be recognized as Tyrannosaurid. But the real breakthrough came in 1900, when Barnum Brown of the American Museum of Natural History unearthed a partial skeleton in Wyoming. 2 years later, he struck gold again in Montana's Hell Creek Formation, over 30 bones from a truly massive predator. In 1905, museum president Henry Fairfield Osborn gave it a name, Tyrannosaurus rex, the Tyrant Lizard King. Osborn had also named Dynamnosaurus imperiosus that same year, thinking it was a separate species. But by 1906, he realized they were one and the same. Tyrannosaurus rex wasn't just big, it was colossal. One of the largest carnivores to ever walk the earth, this apex predator pushed the boundaries of terrestrial gigantism. The most famous specimen, known as Sue, is housed at the Field Museum in Chicago. Measuring over 12 meters or 39 feet from snout to tail, and standing nearly 4 meters or 13.1 feet at the hips, Sue was a tank of muscle and bone. Recent studies estimate her mass at roughly 8.4 tons, possibly more depending on the modeling technique used. But even Sue has competition. Another specimen, nicknamed Scotty, discovered in Canada, may have edged her out in bulk. At an estimated 13 meters or 43 feet long and weighing nearly 8.9 tons, Scotty currently holds the record for the heaviest known T-Rex. Not every adult reached those extremes. Over the decades, body mass estimates for T-Rex have ranged widely, from a lean 4.5 to more than 7.2 tons. Today, most reconstructions place average adult weight somewhere between 5.4 and 8 tons, with individual variation likely influenced by age, growth, and possibly even pathology. A 2024 study, however, found little evidence of size-based sexual dimorphism, suggesting that the largest and smallest adults weren't simply male or female, they were just individual tyrants at different points on the growth curve. Tyrannosaurus had a skull like no other. At over 1.5 meters or 4.9 feet in length, the largest known skulls were thick with bone, braced by fused sutures and honeycombed with air pockets to save weight without sacrificing strength. The rear was massively broad, while the snout remained narrow, a design that gave the animal exceptional binocular vision. This unique cranial architecture wasn't just for show. T-Rex delivered the most powerful bite force of any terrestrial animal, dead or alive. Its skull wasn't just tough, it was also armed. The teeth weren't daggers, they were blunt, bone-crushing columns. The premaxillary teeth were D-shaped in cross-section, tightly packed and strongly curved, ideal for tearing and pulling. Further back, the larger teeth resembled serrated bananas, each one built to resist snapping under immense forces. One tooth, discovered intact with root, was over 13 centimeters or 5.1 inches long, the largest known from any carnivorous dinosaur. The dentary in the lower jaw bore 13 teeth, while the bone behind it thickened dramatically to withstand the crushing stress of each bite. Both upper and lower jaws were riddled with small foramina, tiny holes in the bone that may have supported a crocodile-like sensory system, or possibly lips, a topic still debated among paleontologists. T-Rex's neck was a powerhouse of muscle and bone, built tight and compact to hold up its massive skull. It curved in a sturdy S-shape, made of short, broad vertebrae locked in place by thick, strong tendons. The torso was deep and barrel-shaped, anchored by huge sacral vertebrae fused into a solid, immovable platform that connected firmly to the pelvis. Inside many of these bones, air sacs hollowed them out, lightening the load without sacrificing strength. The tail stretched long and heavy, perfectly balancing the enormous head and upper body. But it was more than just a counterweight. Hidden deep in the tail were some of the strongest muscles in the entire dinosaur, driving powerful strides. Toward the middle, the tail bones grew stiff and reinforced, boosting stability as T-Rex moved. Fossils like Sue show over 40 tail vertebrae, though the exact count may have varied from individual to individual. The arms? Tiny, yes, but not useless. The humerus was short but exceptionally robust, and the two-fingered hands were tipped with powerful claws. A third, vestigial metacarpal remained as a splint of bone, a silent echo of a three-fingered ancestry. The shoulder girdle was massive, with long scapulae and strong connections to the chest. The furcula, or wishbone, likely helped absorb stress during movement. In contrast, the hind limbs were enormous, long, powerful, and built for endurance. They were among the longest proportionally of any theropod. The metatarsals formed an arctometatarsian foot structure, where the central toe was pinched near the ankle, a design that improved stability and transferred force efficiently during movement. Despite its bulk, T-Rex was built to move. Even with such mass, the skeleton remained surprisingly light thanks to extensive hollowing throughout the bones, a hallmark of theropods, and one reason T-Rex wasn't simply a walking boulder. Taxonomically, Tyrannosaurus rex is the gold standard for its group. It's the type genus not only for Tyrannosauridae, but for the entire Tyrannosauroid lineage. Closer relatives like Daspletosaurus and Tarbosaurus have sometimes been folded into Tyrannosaurus, though most modern analyses keep them distinct. Tyrannosaurids were once thought to descend from large-bodied carnosaurs, but are now firmly placed within Coelurosauria, the same broader group that includes birds. The earliest tyrannosaurs, like the crested Proceratosaurids, were small, lightly built predators. Over time, members of this lineage evolved new features: fused nasal bones, octometatarsal feet, reduced arms, and enlarged heads. The more derived members, Pantyrannosauria, developed stronger hips, modified cranial features, and increasingly robust bills. Within this lineage, Yutyrannus show further specializations: reduced external mandibular fenestrae, rough textured nasal bones, and limb proportions that hint at the shrinking arms and deepening skulls of their descendants. By the time true Tyrannosaurids emerged, features like nasal crests and mobile skulls were gone, replaced by rigid, reinforced jaws and crushing bite forces. Tyrannosaurids likely rose to dominance during the late Cretaceous, filling ecological gaps left by the decline of Allosaurids and Megalosauroids. They thrived in both North America and Asia, forming a biogeographic link between the continents. Multiple studies have recovered Tarbosaurus bata as the closest relative of T.rex, suggesting a shared ancestry, perhaps even migration between the continents. The discovery of Lythronax and Tyrannus further cements this idea. Together, these taxa form a tight clade with T.rex, dubbed Tyrannosaurini. Other lineages, like Daspletosaurus and Thanatotherestes, form their own distinct subgroup, Daspletosauridae. A 2024 study describing Tyrannosaurus mcraeensis recovered similar relationships, placing T.rex as the sister taxon to the Asian tyrants. In the end, Tyrannosaurus rex stands not only as the apex predator of its ecosystem, but as the apex of its evolutionary lineage, a product of tens of millions of years of specialization, survival, and supremacy. A hunter forged in bone, muscle, and time. In 2024, Dahlman and colleagues described a Tyrannosaur fossil found in 1983 in New Mexico's Hall Lake Formation, dating from the late Campanian to early Maastrichtian. The remains include parts of the skull, lower jaws, isolated teeth, and chevrons. Some bones were first mentioned in 1984 as possibly belonging to Tyrannosaurus rex, with a more detailed description published in 1986. Back in 1990, Lehman and Carpenter suggested this fossil represented a new Tyrannosaur genus, but later researchers disagreed. By 2015, Sullivan and Lucas argued there wasn't enough evidence to confidently assign it to T.rex. They also proposed the Tyrannosaur lived before the Lancian age, roughly before 67 million years ago, based on its association with Alamosaurus fossils. Dahlman's 2024 study officially named it Tyrannosaurus mcraeensis, after the McRae group rock layers where it was found. This places Tyrannosaurus mcraeensis a few million years older than typical T.rex fossils, which are from the very end of the Maastrichtian. Early estimates dated the layers between about 72.7 and 70.9 million years ago, but newer data suggests the fossil's age might be closer to 69 to 66 million years ago, much nearer to T.rex's time. Tyrannosaurus mcraeensis was around 12 meters or 39 feet long, similar to an adult T.rex, but key differences stand out. Its lower jaw is longer with a less pronounced chin and shallower depth, hinting at a weaker bite. The teeth are blunter and more compressed side to side, and the postorbital crests are less prominent. The skeleton also shares features with Asian tyrannosaurs like Tarbosaurus and Tyrannus. In 2025, Morrison and colleagues raised concerns about the fossil's dating, noting the challenges of using Alamosaurus as a marker due to variable sedimentation rates. They also questioned whether the skull differences were significant enough to separate it from T-Rex. Regardless, they supported the idea that Tyrannosaurus likely originated in Laramidia, and that its ancestors may have migrated from Asia. Later that year, it was concluded that Tyrannosaurus mcraeensis should be considered a junior synonym of T-Rex, since its differences fall within the known variation of T-Rex specimens, and the stratigraphic data remains uncertain. The discovery of feathered dinosaurs sparked debate about whether Tyrannosaurus had feathers. Early finds like the small Tyrannosauroid Guanlong showed filament-like proto-feathers, but larger tyrannosaurs were thought to have lost them, as skin impressions showed scales. However, the discovery of the large, feathered Yutyrannus challenged this size-based idea. A 2017 study of Tyrannosaur skin impressions, including Tyrannosaurus specimen Yutyrannus, found mosaic scales on parts of the body, and suggested that if feathers were present, they were likely limited to the upper trunk. In 2016, some researchers proposed that theropods like Tyrannosaurus had lips covering their teeth, based on enamel hydration needs. Others argued Tyrannosaur snouts had large, flat scales rather than lips, similar to crocodilians, though recent comparisons to lizard skin suggests Tyrannosaurids had squamose or scaly skin instead of crocodile-like texture. In 2023, Cullen and colleagues supported the lips hypothesis by comparing facial anatomy and tooth wear patterns to modern lizards rather than crocodilians. Their analysis showed Tyrannosaur teeth lacked the enamel wear seen in crocodiles, implying lips helped keep teeth moist. They also found tooth size relative to skull length was consistent with teeth being covered by lips when the mouth was closed. For a long time, tyrannosaurs were assumed to be cold-blooded like most reptiles, but during the dinosaur renaissance in the late 1960s, scientists like Robert Bakker and John Ostrom challenged this view, proposing T-Rex was warm-blooded and highly active. Evidence supporting a high metabolism includes bone histology showing rapid growth in young T-Rex, similar to mammals and birds, with growth mostly limited to juveniles rather than continuing indefinitely. Oxygen isotope analysis of fossil bones suggests T-Rex maintained a stable internal temperature with only a small difference between core and limb bones, indicating a homeothermy somewhere between cold-blooded reptiles and warm-blooded mammals. Some researchers warn these isotope ratios can be altered over time, but similar findings in other large theropods support the idea. Even some herbivorous dinosaurs showed evidence of stable body temperatures, unlike contemporary lizards. In 2022, a study using lipoxidation signals metabolic byproducts found Tyrannosaurus and other dinosaurs had metabolisms as high as modern birds, possibly inherited from common dinosaur ancestors. However, homeothermy in T-Rex doesn't guarantee true warm-bloodedness. It could also be explained by gigantothermy, where large size helps maintain stable temperature, like in sea turtles today. Skull openings in Tyrannosaurus may have also helped regulate heat, similar to crocodilians. Scientists have long debated how fast Tyrannosaurus rex could run. Most estimates put its top speed around 9 meters per second, or 32 kilometers an hour, or 20 miles per hour. But some suggest it might have been as slow as 4.5 meters per second, 16 kilometers an hour, or less realistically, up to 20 meters per second, or 44.7 miles an hour. Given its massive, bulky build, around 7 tons as an adult, T-Rex was unlikely to be a sprinter like lighter predators such as Carnotaurus or Gigantosaurus. Fossilized footprints show it was definitely a walker, but none prove it ever ran. A 2002 study modeled the leg muscles required for running above 40 kilometers an hour and found T-Rex would have needed absurdly large leg muscles, up to 86% of its body weight, to pull that off. More reasonable estimates suggest it could only manage walking or slow jogging speeds around 18 kilometers an hour, or 11 miles an hour. Still, T-Rex had some clever adaptations. Its long lower legs and a special foot bone arrangement called an arctometatarsus helped it move efficiently. Recent research shows T-Rex was an exceptional long-distance walker, conserving energy as it roamed to hunt or scavenge. This efficiency meant fewer hunts and less food needed, a huge advantage for such a massive predator. Beyond speed, agility mattered. Studies suggest T-Rex could make quick turns and even pirouette on one foot while chasing prey, much like modern wolves stalking then sprinting to catch food. There's even evidence some Tyrannosaurs hunted in groups. One fascinating study reconstructed how T-Rex's tail swayed like a spring while walking, storing and releasing energy to make its stroll more efficient, with a comfortable walking speed near 1.3 meters per second, or 4.6 kilometers an hour. So, while Tyrannosaurus rex wasn't a racehorse, it was a smart, energy-efficient hunter with surprising agility, perfect for the apex predator it was. Tyrannosaurus rex had well-developed senses similar to other coelurosaur dinosaurs. It could move its eyes and head quickly and precisely, and it had an enhanced ability to hear low-frequency sounds, which may have helped it track prey from a distance. Its sense of smell was also highly developed. A study by Kent Stevens found that T-Rex had excellent vision, with a binocular field of about 55 degrees, wider than that of modern hawks. Its visual sharpness was estimated to be around 13 times better than a human's, even better than an eagle's. Paleontologist Thomas Holtz suggested that this strong depth perception was important because T-Rex hunted large, often armored dinosaurs like Triceratops and Ankylosaurus. Precision in striking would have been crucial for taking down such tough prey. Though no eye bones have been found for T-Rex, estimates based on close relatives suggest it had large eyes adapted for daytime vision, but probably not well suited for low-light conditions. Its sense of smell was especially strong, likely comparable to modern vultures, enabling it to detect carcasses from far away. Interestingly, T-Rex had a long cochlea, which suggests it had good hearing, particularly for low-frequency sounds. Studies also indicate that T-Rex had sensitive snouts and jaws, possibly used to care for nests and young, similar to modern crocodilians. This sensitivity may have helped it detect subtle differences while feeding or interacting socially. Brain studies suggest T-Rex had one of the largest brains relative to body size among non-avian dinosaurs, with cognitive abilities comparable to modern reptiles, and perhaps close to some mammals. There is strong evidence that tyrannosaurs, including Tyrannosaurus rex, sometimes practiced cannibalism. In one specimen, tooth marks were found on foot bones, the humerus and metatarsals, signs that T-Rex fed on members of its own species, likely scavenging them rather than attacking live rivals. Fossils from formations like Fruitland, Kirkland, and Ojo Alamo also show similar bite marks on tyrannosaurid bones, suggesting cannibalism was relatively common in these predators. Researchers believe this behavior was opportunistic. Tyrannosaurs took advantage of carcasses when the chance arose. A 2010 study by Curie, Horner, Erickson, and Longrich examined tooth marks on Tyrannosaurus bones attributed to the same genus. The location of the marks, mainly on less fleshy parts like feet, supports the idea that these were scavenging bites rather than wounds from fights. It would have been difficult for a T-Rex to bite another's feet during combat, making scavenging a more likely explanation. Overall, the evidence points to Tyrannosaurus occasionally feeding on their own kind, especially when other food sources were scarce. Daspletosaurus, meaning frightful lizard, is a genus of tyrannosaurid dinosaur that lived in Laramidia during the late Cretaceous period, roughly between 77 and 74.4 million years ago. This genus includes 3 named species. Fossils of the earlier species, Daspletosaurus torosus, have been found in Alberta, while Daspletosaurus horneri fossils are known only from Montana. Another species, Daspletosaurus wilsoni, has been proposed as an intermediate form, potentially evolving through anagenensis. Daspletosaurus is closely related to the larger, later tyrannosaurid Tyrannosaurus rex. Like most tyrannosaurids, Daspletosaurus was a large bipedal predator, typically measuring between 8.5 and 9 meters, or 28 to 29.5 feet in length, and weighing around 2 to 3 tons. Its forelimbs were small, typical of tyrannosaurids, but proportionally longer than those of other related genera. As an apex predator, Daspletosaurus had dozens of large, sharp teeth and likely hunted large herbivorous dinosaurs, such as the ceratopsid Centrosaurus and the hadrosaur Hypacrosaurus. In some regions, it coexisted with another Tyrannosaurid, Gorgosaurus, though evidence suggests they occupied slightly different ecological niches. While Daspletosaurus fossils are less common compared to other Tyrannosaurids, the specimens that have been found provide valuable insight into its biology, including aspects of social behavior, diet, and life history. The type specimen of Daspletosaurus turosus is a partial skeleton including the skull, shoulder, forelimb, pelvis, femur, and vertebrae from the neck, torso, hip, and the first 11 tail vertebrae. It was discovered in 1921 near Steville, Alberta, by Charles Mortram Sternberg, who initially thought it was a new species of Gorgosaurus. The specimen was fully described in 1970 by Dale Russell, who established the new genus Daspletosaurus. Dale Russell also proposed that an immature Albertosaurus specimen from the younger Horseshoe Canyon Formation in Alberta belonged to Daspletosaurus turosus, potentially extending the genus's temporal range by about 3.5 million years into the Maastrichtian. This reclassification was controversial, and subsequent re-examination favored its original identification as Albertosaurus sarcophagus, despite some features resembling Daspletosaurus. Additionally, some maxilla and teeth fossils from the Horseshoe Canyon Formation were mistakenly attributed to Daspletosaurus, but are now confirmed to belong to Albertosaurus. Although large compared to modern predators, Daspletosaurus was not the largest Tyrannosaurid. One large specimen suggests the genus could grow slightly over 9 meters, or 29.5 feet. Daspletosaurus had a massive skull exceeding 1 meter in length, with heavily constructed and fused nasal bones for strength. Large openings in the skull reduced its weight. Its teeth, numbering around 60, were long and oval in cross-section rather than blade-like. The front teeth in the premaxilla had a distinctive D-shaped cross-section, a heterodont trait common to Tyrannosaurids. Unique features of the skull include a rough texture on the maxilla and pronounced crests around the eyes. The eye socket was a tall oval shape, intermediate between the circular form of Gorgosaurus and the keyhole shape seen in Tyrannosaurus. Daspletosaurus teeth show split carinae, or cutting edges. The body plan was typical for Tyrannosaurids, a short S-shaped neck supporting the heavy skull, and it moved on powerful hind limbs ending in 4-toed feet, with the first digit not touching the ground. The forelimbs were tiny but proportionally longer than in related Tyrannosaurids, and had only 2 digits. A long, heavy tail balanced the body with the center of gravity near the hips. Studies comparing tooth wear suggest a Daspletosaurus had lips that covered its teeth, protecting them from external damage. This means its snout resembled that of modern lizards rather than crocodiles, which lack lips. A rare skin impression attributed to Daspletosaurus turosus reveals small polygonal scales about 3 mm in diameter, though their exact placement on the body is unknown. Daspletosaurus belongs to the subfamily Tyrannosaurinae, within the family Tyrannosauridae, alongside Tarbosaurus, Tyrannosaurus, and Alioramini. Members of this group tend to be robust, with proportionally larger skulls and longer femora compared to the more lightly built Albertosaurinae. Daspletosaurus was part of the tribe Daspletosaurinae, which includes it and Thanatotheristes. Most researchers consider Daspletosaurus closely related to Tyrannosaurus rex, possibly even an ancestor through gradual evolution, anagenensis. Gregory Paul once reclassified it as Tyrannosaurus turosus, but this has not been widely accepted. Some view Tarbosaurus and Tyrannosaurus as sister taxa, or possibly the same genus, with Daspletosaurus as a more basal relative. Recent studies propose that the 3 Daspletosaurus species evolved through anagenensis, leading to later tyrannosaurines like Zhushentyrannus, Tarbosaurus, and Tyrannosaurus. However, some research indicates that the species overlapped in time, suggesting that anagenesis might not fully explain their evolution. The youngest species, Daspletosaurus horneri, is considered the most basal despite its later appearance. The limited fossil record makes it difficult to conclusively determine the dominant evolutionary processes. Daspletosaurus horneri possessed integumentary sensory organs, which might have helped with touch, precise jaw movement, temperature sensing, and detecting prey. Large, flat scales could have protected the snout during hunting and intraspecific combat. Only one Daspletosaurus specimen from Dinosaur Park bears Tyrannosaurus bite marks on its skull, which may represent intraspecific aggression common among predators. Facial biting has been observed in Gorgosaurus, Tyrannosaurus, and other theropods like Cineraptor and Sauronitholestes. Researchers speculate such biting was related to competition for territory, resources, or social dominance. A juvenile specimen initially thought to be Daspletosaurus but later identified as Gorgosaurus libratus also shows healed facial bite marks, indicating survival after aggression. Evidence for social behavior in Daspletosaurus comes from a bone bed in Montana's Two Medicine Formation, containing remains of 3 individuals of different ages alongside several hadrosaur fossils. Geological data suggests the animals were buried simultaneously, and that the Daspletosaurus were feeding on hadrosaurs when they died. While some speculate this indicates pack behavior, others caution the evidence is inconclusive. Alternate views propose social interactions similar to modern Komodo dragons, where individuals gather around carcasses but compete aggressively, sometimes cannibalizing one another. Fossil sites with multiple individuals of Tyrannosaurids like Teratophoneus and Albertosaurus suggest that gregarious behavior may have been common in this family, supporting the possibility of sociality in Daspletosaurus. All known Daspletosaurus fossils come from formations dating to the middle to late Campanian stage of the late Cretaceous, about 78 to 74.4 million years ago. During this time, North America was divided by the Western Interior Seaway, with Montana and Alberta lying on the western landmass of Laramidia. The uplift of the Rocky Mountains was ongoing, creating varied habitats. Daspletosaurus lived in diverse environments, ranging from river plains to coastal floodplains. The Oldman Formation and Judith River Formation, where many fossils are found, contained abundant plant life, from conifers and ferns to early flowering plants. These environments supported large herbivorous dinosaurs like hadrosaurs, Hypacrosaurus, Gryposaurus, ceratopsians, centrosaurus, ankylosaurs, and smaller ornithischians, providing prey for Daspletosaurus. Other carnivores sharing this habitat include the smaller Tyrannosaur Gorgosaurus, dromaeosaurids, and large crocodilians. Let me take you on a wild ride into the world of Tarbosaurus, the alarming lizard that ruled ancient Asia like a nightmarish shadow some 70 million years ago. Imagine a predator so colossal it could swallow a car whole and crush bones like crackers, with a bite force rivaling that of its famous North American cousin, Tyrannosaurus rex. That's Tarbosaurus bata for you. This monster was a heavyweight champ of the late Cretaceous, striding on 2 powerful legs, measuring up to a staggering 10 meters or 33 feet long, about the length of a city bus, and standing nearly 3 meters or 9.9 feet tall at the hips. Weighing in at around 4.5 to 5 tons, it packed enough muscle and menace to dominate the Mongolian floodplains, deserts, and forests it called home. Its skull alone was a terrifying masterpiece of evolution, 1.35 meters or 4.4 feet long. This design meant Tarbosaurus didn't have the same forward-facing, depth-perceiving binocular vision as its American cousin. Instead, its eyes faced more sideways, suggesting it relied heavily on its killer sense of smell and hearing. Those olfactory bulbs, huge, like having a built-in super sniffer that could detect prey miles away. Its brain, while small compared to its massive body, was wired for survival. with impressive nerves that tuned into scents and sounds, turning this giant into an apex predator and expert scavenger alike. But the real jaw-dropper? The jaw itself had a unique-looking mechanism that made its bite nearly unbreakable, and packed with about 60 razor-sharp teeth, some almost as long as a human hand. Most were oval-shaped for slicing flesh, while the front had D-shaped teeth perfect for gripping. Combine that with arms so tiny they'd make even a T.rex blush, just 2 fingers on each hand, basically useless for grabbing but powerful in their own bizarre way. Despite all its might, scientists think that Tarbosaurus wasn't just a brute scavenger. Studies of its bones show signs of injuries consistent with wrestling live prey. Those tiny stress fractures in the hands are like battle scars from grappling with giant herbivores like Saurolophus and armored ankylosaurs like Tarchia. These fossils even reveal bite marks on dinosaur bones, showing it wasn't afraid to hunt the giants of its ecosystem. And it didn't just stomp around alone. Tarbosaurus lived alongside other tyrannosaurs, like Albertosaurus, and close cousins in an ecosystem teeming with massive sauropods and hadrosaurs, making its survival a brutal daily contest. Add in some fascinating clues like fossilized skin impressions showing tiny, non-overlapping scales, almost like reptilian armor, and the rumored discovery of a throat pouch that might have inflated like a colorful balloon for display or communication. Imagine a T.rex with a flashy neck sack. And you've got a creature that's not just fearsome, but eerily sophisticated. Even the brains of Tarbosaurus have been studied using fossil casts, showing surprising similarities with crocodiles rather than birds, a throwback to its reptilian roots, but sharpened through evolution into one of the deadliest hunters ever to walk the earth. So next time you think of the classic T.rex, remember Tarbosaurus, Asia's own terrifying titan, a predator that combined brute force, keen senses, and evolutionary quirks to rule an ancient world filled with giants. It's the stuff of nightmares, fossilized forever in the sands of Mongolia. Like I already mentioned in one of my videos, Gorgosaurus was basically the Tyrannosaurus Ferrari of its time, a sleek, fast, and deadly predator. It was a genus of Tyrannosaurid theropod dinosaur that lived in western North America during the late Cretaceous period, around 76.5 to 75 million years ago. Its fossils have been found mainly in Alberta, Canada, and Montana, USA. Paleontologists generally recognize only one species, Gorgosaurus libratus, although other species have occasionally been misattributed to the genus. Like most tyrannosaurids, Gorgosaurus was a large, two-legged predator measuring between 8 and 9 meters or 26 to 30 feet in length and weighing roughly 2 to 3 tons. Its jaws were lined with dozens of large, sharp teeth, while its forelimbs were notably small with just 2 fingers. Gorgosaurus was closely related to Albertosaurus and more distantly to the larger Tyrannosaurus. The differences between Gorgosaurus and Albertosaurus are subtle, mainly involving details of the teeth and skull bones. Some experts even argue that Gorgosaurus libratus should be classified as a species of Albertosaurus, which would make Gorgosaurus a junior synonym of that genus. This dinosaur lived in lush floodplains along an inland sea and was the top predator in its ecosystem, hunting abundant ceratopsids and hadrosaurs. In some regions, it lived alongside another tyrannosaurid, Daspletosaurus. Though similar in size, these two predators likely occupied different ecological niches. Gorgosaurus is one of the best represented tyrannosaurids in the fossil record, with dozens of specimens providing insight into its growth, behavior, and biology. In terms of size, Gorgosaurus was smaller than Tyrannosaurus or Tarbosaurus, but similar to Albertosaurus. The largest skull found measures about 99 centimeters or 39 inches long, slightly smaller than that of Daspletosaurus. Its skull was large relative to its body size, but had weight-saving adaptations like hollow chambers and large openings between bones. Compared to Daspletosaurus and other Tyrannosaurids, Gorgosaurus and Albertosaurus had proportionally longer and lower skulls. The snout ended bluntly, with fused nasal and parietal bones along the middle of the skull. The eye socket was round rather than oval or keyhole-shaped, and a tall crest projected from the bone in front of each eye, similar to other close relatives. Differences in the bones around the brain also helped distinguish Gorgosaurus from Albertosaurus. The teeth of Gorgosaurus match those typical of Tyrannosaurids. The 8 teeth at the very front of the snout, premaxillary teeth, were smaller, closely packed, and D-shaped in cross-section. The first maxillary tooth resembled these front teeth, while the rest were oval-shaped rather than blade-like. It had 26 to 30 maxillary teeth and 30 to 34 teeth in the lower jaw, similar to Albertosaurus and Daspletosaurus. Skin impressions reported in 2001 from a Gorgosaurus specimen showed mostly smooth skin with very small, widely spaced scales, similar to the featherless skin of large modern birds. Other patches of skin showed denser and slightly larger, yet still fine scales, about the size of those on a Gila monster. None of the skin impressions could be definitively linked to a specific body part. Some traces from the tail show small, rounded, or hexagonal scales. Like other Tyrannosaurids, Gorgosaurus didn't develop its full bite power overnight. During its youth, its bite strength grew gradually, but as it hit the late juvenile phase, that force skyrocketed. Scientists estimated bite force anywhere between about 12,200 and over 40,000 newtons. Recent research tends to favor the lower side of that range, putting it close to what a similarly sized Tyrannosaurus could deliver. One especially cool discovery came in 2023, a juvenile Gorgosaurus fossil that still had the stomach contents preserved. Inside were the remains of 2 juvenile Cetipes lizards, both roughly a year old and much smaller than their predator. This direct snapshot confirms that young Gorgosaurus kept hunting smaller prey even as they grew bigger, showing a clear ontogenetic dietary shift, basically a change in diet as they matured. What's really interesting is that only the hind limbs and tails of the lizards were found, which suggests juvenile Gorgosaurus might have had a taste for the meaty legs. Paleontologist Thomas Holtz Jr. even joked that it was like a prehistoric Thanksgiving dinner. Bone histology studies show that Tyrannosaurids like Gorgosaurus underwent rapid growth spurts lasting around 4 years following a lengthy juvenile phase. Sexual maturity appears to have marked the end of this rapid growth, after which growth slowed significantly. Gorgosaurus grew a bit slower than Tyrannosaurians such as Tyrannosaurus, but at a rate comparable to Albertosaurus. They spent much of their early life as juveniles before quickly reaching near adult size. This growth pattern, combined with the absence of intermediate-sized predators between adults and smaller theropods, implies that juvenile Tyrannosaurids occupied unique ecological roles. This is somewhat similar to modern Komodo dragons, whose juveniles live in trees and feed on insects before becoming powerful apex predators. Unlike some of their relatives, Gorgosaurus shows no clear signs of pack or social behavior, even though mixed age groups have been found in related genera like Albertosaurus. The holotype specimen of Gorgosaurus liberatus displays several injuries and pathologies, including fractured ribs and belly ribs, gastralia, a broken fibula, and abnormalities in some foot bones. In short, Gorgosaurus was a swift, highly adapted predator that dominated its environment, rightfully earning its reputation as the Ferrari among Tyrannosaurids. Meet Albertosaurus, the Alberta lizard, a fierce, sleek predator that stalked northwestern North America roughly 71 million years ago during the late Cretaceous. This Tyrannosaurid wasn't just any big meat eater, it was a master of its domain. roaming the lands that would become modern Alberta, Canada, though tantalizing fossils hint it might have ranged as far south as Mexico. Albertosaurus wasn't quite as massive as its superstar cousin Tyrannosaurus rex, but don't underestimate it. Clocking in at around 8 to 9 meters long, about 26 to 30 feet, and tipping the scales at up to 3 tons, it was still a terrifying apex predator. Picture a bipedal hunter with powerful legs built for chasing down prey, tiny but sharp two-fingered arms, and a massive skull packed with dozens of razor-sharp teeth designed for slicing and crushing. What really sets Albertosaurus apart is just how much we know about it, thanks to the remarkable discovery of over 30 individuals, including a famous bone bed with 26 individuals in one spot. This treasure trove gives scientists an unprecedented peek into its life, how it grew, how it lived, and maybe even how it hunted. The idea that these dinosaurs might have hunted or at least traveled in groups comes from this find, sparking lively debates over whether Albertosaurus was a pack hunter or just a group brought together by fate. Its body shared the classic Tyrannosaur shape, a giant head balanced by a long, muscular tail, small but sturdy forearms, and feet with long toes, optimized for speed. Estimates suggest younger Albertosaurus could sprint up to 20 kilometers an hour, around 30 miles an hour. It was a predator built for power and agility. Skin impressions from Albertosaurus show a pebbly, scaly texture, not feathers, but tough, protective scales that varied across its body. 2 larger feature scales found near its belly are rare among theropods, giving us a unique glimpse into its appearance. Its skull alone was a marvel, about a meter long with large openings to reduce weight and huge jaws holding at least 58 banana-shaped teeth, arranged with special heterodonty, meaning teeth varied in shape depending on their position. The front teeth were smaller and D-shaped, perfect for gripping, while the cheek teeth were built to resist the twisting and pulling of prey struggling for its life. Interestingly, its bite wasn't quite as bone-crushing as T.rex, but still formidable, packing over 3,500 newtons of force. Above its eyes, Albertosaurus sported short bony crests, which may have been brightly colored and used for showy courtship displays, like nature's own version of a dino Tinder profile. Albertosaurus teeth were engineering marvels too. Paleontologist William Abler showed their serrations ended in tiny voids called ampullae that helped prevent cracks from spreading when biting through tough flesh. This clever design parallels human engineering techniques used in guitars and airplanes to control material stress, nature's own high-tech innovation. Taxonomically, Albertosaurus belongs to the Albertosaurinae subfamily, closely related to Gorgosaurus. Compared to the more robust Tyrannosaurines, think Tarbosaurus and T.rex, Albertosaurines had a leaner build with proportionally smaller skulls and longer lower legs and feet, perfect for speed and agility. Thanks to bone histology, the microscopic study of bone tissue, scientists can track the growth of Albertosaurus individuals. The youngest known was just 2 years old, about 2 meters or 6.6 feet long and weighing 50 kilograms or about 110 pounds, while the oldest reached up to 10 meters or 33 feet and lived 28 years. Growth was rapid in a 4-year burst ending at around age 16, adding about 120 kilograms or 265 pounds per year during peak growth, a growth spurt comparable to other Tyrannosaurids, though dwarfed by the explosive growth of T.rex. Remarkably, most Albertosaurus fossils come from the Horseshoe Canyon Formation, a dynamic landscape of ancient rivers, floodplains, and swamps near the edge of the shrinking Western Interior Seaway. This setting, with fluctuating sea levels and diverse environments, created the perfect backdrop for Albertosaurus to thrive. The famous dry island bone bed, with its 26 Albertosaurus fossils of various ages, offers tantalizing hints that these predators might have moved in groups, though Whether it was true pack hunting or just a gathering forced by natural events like droughts is still debated. In the end, Albertosaurus emerges as a fascinating combination of speed, strength, and survival savvy, a key player in late Cretaceous ecosystems, perfectly adapted to its niche, and a captivating window into the world of tyrannosaurs beyond the shadow of T.rex. Tyrannus, meaning Tyrant, is a genus of large tyrannosaurid theropod dinosaur from the Campanian stage of the late Cretaceous, discovered in Shandong Province, China. It belongs to the Tyrannosaurinae subfamily and contains a single species, Tyrannus magnus. First described in 2011 by David Hone, Kebai Wang, and colleagues, the genus name honors the location where it was found, while the species name, Magnus, Latin for great, refers to its impressive size. Tyrannus is known primarily from the holotype specimen, which includes a nearly complete right maxilla and an associated left dentary, both bearing teeth. These fossils were discovered around 2010 alongside the ankylosaur Sinankylosaurus and are housed at the Zhucheng Dinosaur Museum. The specimen comes from the Hongtuya Formation of the Guangxi Group, collected in Zhucheng City dating to at least 73.5 million years ago during the Campanian. This site was a late Cretaceous floodplain famous for one of the world's richest concentrations of dinosaur fossils. Other Tyrannosaurid remains from the same quarry, including a second dentary and maxilla, suggest the presence of at least one additional Tyrannosaur species in the area. Along with these predators, fossils of ceratopsians like Sinoceratops, hadrosaurids, probably Shantungosaurus, and ankylosaurs, such as Sinankylosaurus, have also been found. As a large carnivorous theropod, Tyrannus is estimated to have been similar in size and shape to Tarbosaurus, measuring about 10 meters or 33 feet in length and weighing around 3 tons. However, its jawbones are notably smaller than those of the largest Tyrannosaurus rex specimens, like the famous Sioux. Tyrannus can be distinguished from other tyrannosaurines by a unique feature: a horizontal shelf on the lateral surface at the base of the ascending process of the maxilla, along with a rounded notch on the front edge of the maxillary fenestra. Its antorbital fenestra's lower margin sits well above the ventral rim of the antorbital fossa, and the maxillary fenestra itself measures more than half the distance between the front margins of the antorbital fossa and the fenestra. Unlike Tarbosaurus, Tyrannus lacks a subcutaneous flange on the upper rear part of the maxilla's jugal ramus and does not have a ventrally convex palatal shelf covering the roots of the rear teeth. Some isolated teeth from the Zhucheng dinosaur quarries, previously named Tyrannosaurus zhuchengensis, may belong to Tyrannus, or a related species. These teeth show serrations extending all the way to the base of the tooth crown, a trait unique among tyrannosaurines, though known Tyrannus teeth are too poorly preserved to confirm this link. Phylogenetic analyses place Tyrannus as the closest known relative of Tarbosaurus. These studies suggest that Asian tyrannosaurids like Tyrannus descended from a North American ancestor that also gave rise to Tyrannosaurus rex. More recent research from 2020 supports this, recovering Tyrannus as sister to a clade-containing Tyrannosaurus and Tarbosaurus. Lythronax is a genus of tyrannosaurid dinosaur that roamed North America roughly 81.9 to 81.5 million years ago during the late Cretaceous period. Its discovery came from a partial skull and skeleton found in 2009 within the Waweb Formation of Utah's Grand Staircase Escalante National Monument. Officially named in 2013, Lythronax argestes translates to Gore King, with the species name referencing the southwest wind from Greek poet Homer, alluding to its geographic origin. Estimates of Lythronax's size range from 5 to 8 meters in length, about 16 to 26 feet, and between 500 kilograms and 2.5 tons. It's 1,100 to 5,500 pounds in weight. It was a robustly built Tyrannosaurid, featuring the characteristic small, two-fingered forelimbs, powerful hind limbs, and a broad, heavily constructed skull. Notably, the rear of its skull was especially wide, with forward-facing eye sockets similar to those of Tyrannosaurus, enhancing its depth perception. Lythronax had 11 tooth sockets in its upper jaw's maxilla bone, fewer than most Tyrannosaurids, and the front teeth were the largest, with some reaching nearly 13 centimeters or 5 inches in length. Unique features of its skull included an S-shaped outer edge of the maxilla and an ankle bone projection that extended further upwards compared to closer relatives. The holotype specimen comes from the Campanian stage of the late Cretaceous and is the oldest known Tyrannosaurid. This makes Lythronax crucial for understanding the early evolutionary history of Tyrannosaurids and the development of their distinct anatomical traits. The forward-facing eyes likely gave Lythronax enhanced depth perception, useful for ambush or pursuit hunting strategies. Initial reports at the time of its naming suggested it measured around 7.3 to 8 meters or 24 to 26 feet long, and weighed approximately 2.5 tons or 5,500 pounds. Drawing comparisons to the much larger Tyrannosaurus and noting the possibility of even greater size. However, later research, including by paleontologist Gregory Scott Paul, proposed more conservative estimates, closer to 5 meters or 16 feet in length and 500 kilograms or 1,100 pounds in weight. Regardless of size, Lythronax shared the typical Tyrannosaurid build: small forelimbs with 2 fingers, strong hind limbs, broad jaws, and a robust skull. While earlier, smaller Tyrannosaurids may have had proto-feathers, it remains uncertain whether Lythronax retained these or not. The skull of Lythronax was relatively short and broad. Its width was over 40% of its length, similar to other Tyrannosaurids. Its nasal bones were uniquely wider at the front than the middle, unlike in other relatives. The skull's outer edges, formed by the maxilla and jugal bones, were distinctly S-shaped, contributing to a broader rear skull with nearly forward-facing eye sockets. Such features are only seen in Tyrannosaurus and Tarbosaurus among Tyrannosaurids, while earlier, more primitive relatives had narrower skulls and less forward-facing eyes. Additional distinctive traits included the narrow grooves separating the frontal bone's contacts with adjacent skull bones, and robust, strongly curved maxillae with 11 tooth sockets, an uncommon count shared only with Teratophonius and Bister-Hyversor. The front teeth were large, serrated and banana-shaped, with some almost 13 centimeters or 5.1 inches long. The jugal bone was stout with a broad upward projection connecting to the postorbital bone, indicating a larger subocular flange, unlike smaller versions seen in other Tyrannosaurids. The lower jaw's dentary was concave outward, mirroring the upper jaw's maxilla and matching the expanded rear skull shape seen in Tyrannosaurus and Tarbosaurus. The postcranial remains are limited. The pubis and hind limb elements show typical Tyrannosaurid features, such as a large pubic boot with a forward projection, comparable to that in Tarbosaurus and Tyrannosaurus. The fibula exhibited a deep midline depression, and the ankle's astragalus had an ascending process expanded further upwards than in closer relatives. During the late Cretaceous, the western interior seaway divided North America, isolating the western landmass known as Laramidia. This geographic separation fostered highly distinct ecosystems, often categorized into northern and southern provinces, though this division is debated. Tyrannosaurids, found only in Asia and Laramidia, experienced faunal exchanges between these regions. The evolutionary history of these Tyrannosaurids is complex, particularly with diverse southern Laramidian genera like Lythronax and Teratophonius. complicating the picture. Whether Tyrannosaurus originated from Asian or southern Laramidian Tyrannosaurids remains unresolved. Phylogenetic studies have grouped Lythronax with southern Laramidian Tyrannosaurids, suggesting a biogeographic division between northern and southern forms with limited interchange. These studies also propose a single migration event of Tyrannosaurids from North America to Asia during the late Campanian, preceding Tyrannosaurus's emergence. Lythronax stands out among Tyrannosaurids for its shortened, broad skull and strongly forward-directed eyes, traits shared only with Tyrannosaurus and Tarbosaurus. These forward-facing orbits increased binocular vision and depth perception, enhancing its ability to judge distances during hunting, whether in chasing prey or ambushing. Like its relatives, Lythronax possessed adaptations for a powerful predatory lifestyle. Large body size, strong jaws with robust teeth designed not only for slicing flesh but also crushing bone, and reinforced skull sutures to withstand immense bite forces. Its fused, arched nasal bones and solid sutures helped absorb the stresses of biting, underscoring its role as an effective apex predator in its ecosystem. Nanosaurus, whose name means polar bear lizard, is a genus of tyrannosaurine theropod dinosaur from the late Cretaceous, specifically the Middle Maastrichtian Age, found in Alaska's Prince Creek Formation on the North Slope. It lived about 70 to 68 million years ago and includes just one species, Nanosaurus hoglundi, known from a partial skull and several other fossil fragments like teeth and postcranial bones. Before scientists officially described a Nanosaurus, many tyrannosaurid teeth had already been discovered in the same formation. These were initially assigned to the genus Gorgosaurus. Later, after researchers realized the fossils were from a younger layer, the teeth were reclassified as Albertosaurus remains. In 2006, a medium-sized theropod's fossilized remains were uncovered at the Kikak-Tegosiak quarry in the Prince Creek Formation. The finds included multiple skull fragments, all believed to come from a single individual. Among these were parts like the nasal branch of the right maxilla, pieces of the skull roof, frontals and parietals, a bit of the right laterosphenoid, and part of the left dentary. These fragments helped estimate the skull length at roughly 60 to 70 centimeters, or 2 to 2.3 feet. Radiometric dating of nearby rock layers placed the fossils at about 68 to 70 million years ago. It wasn't until the fossils were prepared and studied at the Perot Museum of Nature and Science in Dallas that researchers recognized these remains belonged to a new genus, not one of the previously named Tyrannosaurids. This discovery led Anthony Fiorio and Ronald Tchaikovsky to officially name and describe Nanosaurus in 2014. The Nanosaurus combines Nanok, the Inupiaq word for polar bear, and the Greek saurus, meaning lizard. The species name, Hoglundi, honors philanthropist Forrest Hoglund for his contributions to cultural institutions. Early estimates put Nanosaurus at about 5 to 6 meters or 16 to 20 feet in length, roughly half the size of a Tyrannosaurus rex. Its weight was estimated between 500 and 900 kilograms, 1,100 to 2,000 pounds. This smaller size was thought to be an adaptation to its Arctic habitat. However, later discoveries of additional fossils along a 20-kilometer stretch of the Colville River suggested this dinosaur might have been much larger than initially believed, possibly reaching sizes similar to Albertosaurus, which could grow 8 to 9 meters or 26 to 30 feet long. Some bones resembled those of a juvenile Tarbosaurus, scaling to about 7 meters or 23 feet. These newer fossils imply adult Nanosaurus might have weighed over 1.9 tons. Anatomically, Nanosaurus likely looked similar to other large tyrannosaurines, like Daspletosaurus, sharing close relations and probably similar ecological roles. Nanosaurus is distinguished by specific skull features, a thick, forked median spur on the fused parietals of the skull roof that overlaps the frontals within the sagittal crest, frontals with a long, pointed process separating the prefrontal and lacrimal facets, and notably, the first two teeth in the lower jaw are much smaller than the ones behind them. Studies of Nanosaurus and other Alaskan dinosaur fossils from the same formation reveal that the Prince Creek Formation preserved a remarkably high number of juvenile dinosaurs across multiple groups. Fossil evidence shows young specimens from 7 major clades, representing around 70% of the dinosaur families found there. These include Hadrosaurids, Leptoceratopsids, Ceratopsids, Tyrannosaurids, Dromaeosaurids, Troodontids, and birds. This diversity of young animals suggests that both Nanosaurus and its prey stayed in the Paleoarctic year-round, enduring roughly 120 days of continuous winter darkness rather than migrating to escape the harsh conditions. It's proposed that these dinosaurs laid their eggs near the start of the continuous daylight period, around April, so the eggs could incubate during the warmer, brighter months. Nanosaurus lived during the Edmontonian faunal stage of the early-late Maastrichtian, inhabiting a region at about 80 to 85 degrees north paleolatitude. This environment was unlike most dinosaur habitats, experiencing temperature swings from about 10 to 12 degrees Celsius, 50 to 54 degrees Fahrenheit in summer, to about -2 degrees Celsius or 28 degrees Fahrenheit in winter, alongside 4 months of near-total darkness. Unlike the large herbivores Edmontosaurus and Pachyrhinosaurus, which favored coastal lowlands and uplands respectively, Nanosaurus appears to have been widespread throughout the Prince Creek Formation landscape. Due to the colder climate, many ectothermic or cold-blooded groups common elsewhere are missing from this formation. This suggests that animals thriving in this high-latitude environment were likely endothermic to some extent, maintaining body heat internally to survive the extreme Arctic conditions. Teratophaneus, meaning monstrous murderer from the Greek teres, monstera, and phaneus, murderer, is a genus of Tyrannosaurian theropod dinosaur that lived during the late Campanian stage of the late Cretaceous, approximately 76.5 to 75.5 million years ago. Its fossils were discovered in what is now Utah's Kaiparowits Formation. The genus includes a single species, Terrapophaneus currayi, named in honor of the renowned paleontologist Philip Currie. The first fossils attributed to Teratophaneus were found in the Kaiparowits Formation, a rich late Cretaceous deposit dated by argon-argon radiometric methods to between 76.1 and 74 million years ago, placing Teratophaneus squarely in the Middle Campanian. Since the initial discovery, several additional specimens have been assigned to this genus, expanding our understanding of its anatomy and diversity. The holotype consists of a fragmentary skull and parts of the postcranial skeleton. Though originally thought to represent multiple individuals, the fossils likely belonged to a single subadult animal. Early estimates by Carr and colleagues put the length at about 6 meters or 20 feet and weight near 667 kilograms or 1,470 pounds. However, these figures are now considered conservative. Gregory Scott Paul later estimated a maximum adult length of roughly 8 meters or 26 feet and weight around 2.5 tons. In 2021, a revision based on frontal bone size comparable to that of Lythronax placed the subadult specimen at approximately 6.1 meters or 20 feet in length. Compared to Albertosaurus, Teratophaneus' skull is roughly 26% shorter between the lacrimal bone of the antorbital fenestra and the snout tip, but notably deeper. This increased depth likely accommodated more robust jaw muscles, enhancing bite force and making Teratophaneus a powerful predator. Phylogenetic analysis confirmed Teratophaneus as a member of the Tyrannosaurine subfamily, closely related to Tarbosaurus and Tyrannosaurus. However, it occupies a more basal position within the group, more derived than Daspletosaurus. One of the most significant discoveries linked to Tyrannosaurus comes from the Rainbows and Unicorns quarry in southern Utah's Kaiparowits Formation, where fossils from 4 or 5 individuals ranging from juveniles to adults were found together. This bone bed suggests a mass mortality event, possibly due to flooding, and supports the hypothesis that Tyrannosaurus may have exhibited social pack-hunting behavior. Such evidence aligns with similar bone beds of Albertosaurus and Daspletosaurus, indicating that gregarious behavior might have been widespread among Tyrannosaurids. The Kaiparowits Formation, where Tyrannosaurus lived, represents an ancient floodplain environment on the western shore of the Western Interior Seaway during the late Cretaceous. This vast inland sea split North America into 2 landmasses, Laramidia to the west and Appalachia to the east. The formation's environment featured large river channels, wetlands, peat swamps, ponds and lakes, bordered by upland highlands. The climate was warm and humid, supporting a diverse array of terrestrial life. Today, the Kaiparowits Formation offers one of the most complete and continuous fossil records of late Cretaceous terrestrial ecosystems in the world. Electrosaurus, whose name means a lone lizard, was a medium-sized Tyrannosauroid dinosaur that lived about 96 million years ago during the late Cretaceous in what is now Inner Mongolia, China. It was roughly 5 to 6 meters or 16 to 20 feet long and weighed around 450 to 900 kilograms or 1,000 to 2,000 pounds, making it smaller and lighter than its famous relative Tyrannosaurus rex. What sets Electrosaurus apart is its build. It had long, slender hind limbs that made it a fast runner, likely specialized for chasing down prey. Unlike the bulky and powerful tyrannosaurs of later times, Electrosaurus's legs were built for speed and agility, suggesting it was a pursuit predator. The first fossils were found in 1923 during an American Museum of Natural History expedition led by Walter Granger. Assistant paleontologist George Olson uncovered nearly complete right hind limbs and other bones in the Irene-Dabasu Formation. These fossils were formally described in 1933 by Charles Gilmore, who named the dinosaur after Olson. Interestingly, some bones once thought to be part of Electrosaurus, like certain forelimbs, turned out to belong to other dinosaur groups, showing how tricky it can be to piece together incomplete fossils. Because the known remains are mostly limited to legs and a few other bones, scientists aren't entirely sure where Electrosaurus fits in the Tyrannosaurid family. The environment it lived in was a lush floodplain with plenty of rivers and vegetation, home to many herbivorous dinosaurs. Electrosaurus's speed would have been a big advantage for hunting in this diverse ecosystem. Studies show its leg proportions were quite specialized. The tibia and femur lengths were almost equal, and the foot bones were long and slender, similar to fast-running modern birds. This contrasts with later, more massive tyrannosaurs that had stockier legs built more for power than speed. Overall, Electrosaurus was a lean, agile hunter in a time and place where most large predators were heavier and slower. It's a fascinating example of how Tyrannosauroids evolved a variety of body shapes and hunting strategies before the rise of the giant, heavyweight tyrants of the very late Cretaceous.